So what if an AI could not only direct a movie, but also turn around and write a brilliant review of it, explaining every single creative choice it made? Well, today, we're diving into a groundbreaking new AI model called Uni-ViGU, which is taking a huge step closer to that exact reality. We're talking about an AI that doesn't just generate video, but can deeply understand it at the very same time. Okay, so let's get right into it. The central question for years has really been this. Can you build a single AI that's both a master filmmaker, someone who can create stunning, original visuals from nothing, and also a master film critic who's able to describe all the nuance and detail with incredible precision? That's the monumental challenge this research tackles head-on. Just take a look at this scene of a nurse in a courtyard and this incredibly detailed paragraph describing it. They weren't created separately. Nope. They were generated at the exact same moment by the same unified intelligence. This is the story of a radical new way of thinking about how to build artificial intelligence. To really get why this is such a game changer, we first need to talk about the dream that's been driving AI research for years, this quest for a truly unified intelligence. You see, the ultimate goal here is to build one single, elegant model that can both create visual media, like videos and images, and also understand it in a way that's much, much closer to how we humans process the world. This wouldn't just make AI development more efficient. It could be a critical leap towards a more general, adaptable artificial intelligence. But there has been one enormous problem standing in the way of this dream. And it all comes down to a massive, fundamental imbalance in the amount of raw computing power these two tasks require. Okay, so on one side, you've got video generation, creating a video from text. This is computationally massive. It involves all these little steps of what's called denoising. Just picture a sculptor starting with a fuzzy block of digital noise and slowly, step by step, chipping away until a coherent, moving image appears. Then, on the other side, you have video understanding, just describing what's in a video. Computationally, this is way, way lighter. And that huge gap in cost has been the roadblock for so long. And when I say massive, how massive are we talking? Well, to generate a single 5-second high-def video, a model might have to process millions of tokens. You can think of tokens as the basic building blocks of information for an AI, kind of like words are for us. Processing millions of them is just an astronomical cost, making it incredibly difficult to combine that heavy lifting with the lighter task of understanding in one model. And this is where the researchers behind Uni-ViGU had their incredible aha moment. Faced with this impossible imbalance, they didn't just try to optimize the old way. No, they decided to flip the entire blueprint for how to build a unified AI on its head. The paper puts it perfectly. It says that the prohibitive costs motivate a natural inversion of perspective. So instead of asking how to add the heavy, expensive task of generation onto a lightweight understanding model, they asked a completely different question. You see, the old way was to start with a model that's already good at understanding and describing things, and then try to bolt on the incredibly resource-intensive job of video generation. This whole approach has just proven to be inefficient and pretty much impossible to scale up effectively. But the new idea is just brilliantly simple. You start with a model that's already doing the heavy lifting, a powerful video generator, and instead you teach it the much lighter task of understanding. So the key takeaway is this. Instead of trying to build a skyscraper on top of a small house, they decided to build on the strong foundation that was already there. It's a total paradigm shift. So how exactly did they pull this off? Let's take a moment and break down the 3 big, clever ideas that make the Uni-ViGU model work so well. First up, they created a process called Uniflow to handle both video and text in one go. Second, they used a very smart mixture of experts architecture. And you can think of it like having a team of specialists where each one is an expert in a specific task. And third, they developed this brilliant 2-stage training method. So let's start with Uniflow. The big challenge is that different types of data, or modalities, are structured really differently. Video is continuous data. It's pixels flowing through time, while text is discrete data, made of distinct words. Uniflow is a single mathematical framework that can generate both of these together, elegantly solving that deep architectural mismatch. Now, what's really interesting here is how they tweaked the AI's internal structure. A standard generator uses shared components to process everything. But with Uni-ViGU, they keep the shared attention part, which is great at understanding relationships, but then they create separate specialized FFN layers. Think of these as specialized processing units. So now there's one expert for video and one expert for text. This lets the model reuse its core knowledge while letting each specialist do what it does best.
And this brilliant architecture is brought to life with an incredibly clever two-stage training process. Let's dig into how this works, because it's a journey that takes the AI from simple recall all the way to true comprehension.
So in stage 1, knowledge recall, they do something remarkably efficient. The generator already knows how to turn a simple prompt like a dog on a skateboard into a video. So for this first stage, they just teach it to do the reverse. Look at the video it just made and spit out the simple prompt, a dog on a skateboard. This isn't about new learning, it's about activating the knowledge it already possesses. Then comes stage 2, capability refinement. Now, the AI is shown videos paired with much richer, more detailed descriptions. To generate this complex text, it can't just rely on its memory of a simple prompt. It's forced to look closely at the actual visual details in the video, the colors, the textures, the specific actions. This is where it learns genuine understanding. It's like going from simply recognizing a dog to being able to describe its breed, its color, and even its mood.
So, what's the payoff for all of this clever engineering? What can Uni-ViGU actually do? And maybe more importantly, what does this new approach mean for the future of AI? And this just illustrates the result perfectly. The model can generate this beautiful cinematic shot of an apple, and at the exact same time, it writes a detailed, almost poetic description of the scene, capturing the light, the water droplets, and the rustic atmosphere. Or look at this one. It creates a video of a waiter on a porch and simultaneously describes the scene with incredible fidelity, mentioning the silver tray, the orange beverage, even the seagulls flying in the background. The video and the text are born together, perfectly and instantly aligned. It's an amazing thing to see. So, the crucial point is this. By flipping the script and starting with a powerful generator, Uni-ViGU demonstrates a more efficient, scalable, and principled way to build these unified AI models. This generation-first approach could very well be the blueprint for the next wave of truly creative and maybe even self-aware artificial intelligence. And this leaves us with a fascinating question to think about. What happens when an AI can not only create a world, but also explain its own creation with perfect clarity? When it's both the artist and the art critic, what entirely new forms of creativity, collaboration, and understanding are even going to be possible?